the last 3 months, because of COVID-19, schools have been shut. I hope that these materials that we present today will be beneficial to students in their final year of secondary or high school.
Hi viewers, you are welcome to another episode of mathematics class, where I'm going to be taking you on the same topic, trigonometry. But today we're going to be talking about the angle of elevation and depression. If you remember, in our last class we talked about the Pythagoras theorem. We have talked about the sine rule. We have talked about the cosine rule. And I've already explained about the applications, the numerical applications of the sine rule, cosine rule, and the Pythagoras theorem. But today, we're still going to be looking at an application of the sine rule and cosine rule to the angles of elevation and depression. So today, what is an angle of elevation? The angle of elevation is the angle between normal eye level, that is the horizontal line, and the line through which an object is above the observer's eye. If you look at what we have here, this is an horizontal line, a straight line. That is an horizontal line. This is the observer. So it's looking at this star with the angle of elevation, that is looking up to the star which is above the eye level. But the horizontal level is directly through the eye. That is the horizontal level. This is the observer. This is where the angle of elevation formed. And this is the object the observer is looking at. So now, if you look at this pictorial diagram, this tall man, you see that is looking down, and this is the short man. This short man that is looking up to the tall man. If you look at it, this is an horizontal line, which is at the same level with the eye level of the observant. This short man is the observant, while this tall man is what the short man is looking at. So the angle of elevation formed at this angle. So I believe that you understand what angle of elevation means. Now, if you look at the angle of depression, is the angle between the horizontal line and the line through which the object, which is below the observer's eye, can be seen. Now, look at the horizontal line. This is the observant. This is the horizontal line. That is at the eye level of the observant. Then it's looking down to the what? To the object, which is the star. So now the angle of depression formed at this angle. If you look at this pictorial diagram again, this is the tall man, which is looking at the short man down here. That is looking depressed. Depression, that is, you're looking downward. Now, look at the horizontal line at this point. Then it's looking down to the short man, which means the angle of depression is going to form at this point. So now, let's look at the height and distance. You know, whenever we're talking about the height and distance, we are just talking about, maybe we want to calculate the distance from one place to another, or the height that it's obtained. That is, the height and distance deal with calculating the height and distance of inaccessible objects. And the method used in angle of elevation and depression may not be appropriate in certain cases. So the various methods to be adopted here will depend on the questions. So it depends on the question that is being given to you. That is when you are going to know whether you are going to adopt the method for the height and distance or not. So however, understanding of trigonometrical ratio is very relevant. Now, look at this example. Let's go to this example. The example states that a ladder 30 meters long rests against a vertical wall. If the ladder makes an angle of 63 degrees with the wall, don't forget, look at that clause, with the wall. Find the distance between the foot of the ladder and the wall. If you look at the diagrammatic illustration, I make use of this line AC to be the wall, while I make use of line AB to be the ladder. So if this is the wall, which is line AC, this is the ladder, which is line AB or BA. it rests on the wall, which makes an angle of 63 degrees with the wall. They said with the wall. That is, this ladder and the wall makes an angle of what? 63 degrees. Then I said, find the distance between the foot of the ladder. B is the foot of the ladder and the wall. C is the foot of the wall. If you look at it from the question, they said the ladder is 30 meters long. That means the length of the ladder is 30 meters. So that is the reason why it's being represented using this diagrammatic illustration. So what we're looking for is the distance between the foot of the ladder and the wall. That is the reason why I make x to be that distance. Now, to find the value of x, that is the distance between the foot of the ladder and the wall, using the word SOHCAHTOA. You know that if you look at it, the angle formed at this angle A and is facing the distance between the foot of the ladder and the wall, which is x. And the side that is given is the hypotenuse side, which is the length of the ladder, which simply means opposite over hypotenuse, and that is sine. That is the reason why we're making use of the SO, and the SO is opposite over hypotenuse. So now, what is our opposite? The opposite is x, while the hypotenuse is 30. That is why we substitute, and the angle formed at the angle A is what? 63 degrees. That simply means at this point, we're going to cross multiply. Then x will be equal to 30 multiplied by sine 63 degrees. And if we multiply 30 by sine 63 degrees, we're going to have 26.73 meters. So hence, the distance between the foot of the ladder and the wall is 26.73 meters. You see, that is very simple. Let's look at the second example. The second example stated that a man is at a point 20 meters away from the foot of a tree. From that point, the angle of elevation of the top of the tree is 43 degrees. Calculate the height of the tree. Don't forget, they said a man is at a point 20 meters away from the foot of a tree. So I make use of line AC to be the length of the tree. I make use of what? The B to be the man that is standing, looking at the top of the tree at an angle of elevation of 43 degrees. That simply means the angle of elevation will form at this angle B. That is why the angle of elevation at this point is 43 degrees. Then I said, where the man is standing to where the tree is there, the distance between them is 20 meters in between. That simply means if from line BC is 20 meters, then we know the angle of elevation to be 43 degrees. Then we were asked to find the height of the tree. That means the height of the tree is being represented with what? X. So which simply means where the angle formed is facing line AC, which makes line AC to be the opposite side. And line BC will be the what? Adjacent side. That's the reason why if we are to find the height of the tree, we're going to be making use of the word SOHCAHTOA. And opposite over adjacent, they are referring to what? Tan, which is opposite over adjacent. Now, tan theta equal to opposite over adjacent. And what is the theta? That is 43 degrees, equal to the opposite, which is x, over the adjacent, which is the 20. Now, if you cross multiply, that simply means the height, which is x, equal to 20 multiplied by tan 43 degrees. And x is going to now be equal to 18.65 meters. So hence, the height of the tree is now what? 18.65 meters. So now, let's look at the third example that we have here. The third example states that a boy observes that the angle of elevation of the top of a tower is 32 degrees. He then walks 8 meters towards the tower and then discovers that the angle of elevation is 43 degrees. Find the height of the tower. Look at the diagrammatic illustration here. The boy is, I represent it with B. The tower, I represent it with what? Line AC. Now, a boy is standing at this point, looking at the top of the tower, and note that the angle of the elevation of the top of the tower is 32 degrees. That is why the angle of 32 degrees formed at this point. He then walks from B, he walks 8 meters towards the C, which is the tower. He walks towards to the point of this D. And now look at the top of the tower again and observe that the angle of elevation that formed is 43 degrees. Now the question says we should find the height of the tower. You know, we know from this movement, the movement of the boy from B to D is 8 meters. But we don't know from D to C, which is to the tower. That is why we represent it with what? X meter. But this is the height we are looking for. If you look at this diagram, we have A, B, C, and D, which simply means it comprises of two triangles, which is triangle ABC and triangle ADC. Now, since we don't know from D to C, because it wasn't given, we represent it with X. That simply means we're going to do what? Make use of the word SOHCAHTOA in order to balance this equation. Now, to find the value of height, which is H, using the word SOHCAHTOA. If you look at it, I told you earlier that we have two triangles here. Triangle ABC and triangle ADC. So let's look at the first triangle ABC. So from the triangle ABC, you look at it that the angle is facing this side, which makes this side to be opposite. And the total length of B to C is the what? The adjacent. Now, that simply means opposite over adjacent is going to be tan. That is the reason why we make use of tan theta to be what? Opposite over adjacent. And what is the theta there? Is 32 degrees, which equal to the opposite is the H, which is the height there, over the adjacent. Adjacent is the total length. That is the length B to C. We know B to D to be 8, and D to C we represent it with X. That simply means BC will be 8 plus X. That's the reason why we make use of 8 plus X at this point. So now, if we are to cross multiply, we're going to make height as the subject. That means the height is going to be equal to 8 plus X multiplied by tan 32. That is our equation 1. Looking at the triangle ADC, this angle 43 is also facing the opposite of H there, and over what? The adjacent of the X meter. So which simply means that is also tan. Tan theta equal to opposite over adjacent, which is going to give us tan 43 equal to height, which is H over X, which simply means we're going to cross multiply. If we cross multiply there, our height is going to give us X multiplied by tan 43, which gives us the equation 2. If you look at the equation 1, height is equal to what we have here, and equation 2, height is also equal to what we have here. That simply means we're going to equate both the equation together. So equating the equation 1 and 2, then we have height is equal to height, and 8 plus X multiplied by tan 32 is equal to what? X times tan 43. That is what we now have here. So from there, we cannot do what? Expand. We are expanding the left hand side. I think it's the tan 32 will multiply 8 and it's going to multiply what? X. That is what we did here, which equal to X tan 43. So at this point, X is at this point and X is here. What that simply means we're going to do what? Collect the like terms. So collecting the like terms, I take X tan 32 degree to this side, which makes it to be what? X tan 43 minus X tan 32 equal to 8 tan 32. So if you now make X, because X is common, I bring S at this point, and it's going to left with what? Tan 43 inside the bracket minus tan 32 equal to 8 tan 32. Now we're looking for the value of X by doing what? Divide all through by tan 33 minus tan 32. Now if we divide all through by what we have here, we're going to have X equal to 8 tan 32 over tan 43 minus tan 32. So 8 multiplied by tan 32 is going to give us 4.9990 over tan 43 minus tan 32 will give us 0.3076. And if we divide that, we're going to have 16.25 meter. So, and at the end of the day, don't forget that's the value of X. But what we have to find is the height of the tower. That simply means we are going to substitute the value of X into the first equation or the second equation. But substituting into the first equation, we're going to have height equal to 8 plus X, and our X is what? 16.25 multiplied by tan 32. If we add this together, we're going to have 24.25 multiplied by tan 32. And by the time we multiply it, we're going to get 15.15 meter. And if you still do the same thing to the equation 2, we're still going to have the same 15.15 meter, which makes us half the height of the tower to be 15.15 meter. As you can see, it's very, very easy to calculate. So I really appreciate you for listening to today's class, and I wish you the very best until we meet again. But before then, stay safe. I wish you good luck. Thank you.